Students, today we are going to solve non-homogeneous differential equation by using all the three methods. If right hand side of a given second order non-homogeneous linear differential equation is e power of x, then it is a first method, and if it is sin x or cos x, then it is a second method, and if it is x to the power of n, third method. We did all types of problems. On method 1 we did, method 2 we did, and method 3 we did. Now combination of these methods, not a single method. We did problems on each single method. Now we solve the problems on combination of these methods. Uh, so that is today's topic. That's it. So directly we know the methods. The first method, when e power of ax is in right hand side, and the second method in right hand side sin x or cos x, and third method right hand side x to the power of m. So you know it. Now methods are known, well explained already. So let me directly go to the problems. So let me go to the problem. The first problem, you see, the problem number 1. Solve d square plus 1 of y is equal to e power of 2x plus sine 3x. You see the problem. Solve d square plus 1 of y is equal to what is in right hand side. You see it. What is in right hand side, guys? The right hand side we are having e power of 2x plus sine 3x. So what it indicates? What is that right hand side tells us? So first term e power of 2x and second term sine 3x. So first term you have to solve particular integral by using the method 1, and the second term we have to solve the particular integral by using the method 2. So this is combination of two methods. So such a problems are more likely to become in examination because it involves the two methods. It checks our knowledge, it verify our knowledge on two given methods. So that's why the combination problems are more frequently comes in examination. Are getting, guys? So this is the problem. Solve d square plus 1 of y is equal to e power of 2x plus sine 3x. So since right hand side is non-zero, therefore the given differential equation is non-homogeneous. Once a given differential equation is non-homogeneous, the general solution is y is equal to yc plus yp. Are you getting? Now yc, complementary function. So what is yc? What is complementary function? It is a general solution of corresponding homogeneous differential equation. So corresponding means for a given non-homogeneous, take right hand side 0, that will becomes its corresponding homogeneous differential equation. So take right hand side 0, so what will get? The auxiliary equation, you get m square plus 1 is equal to 0. That is m square is equal to minus 1. M is equal to plus or minus square root of minus 1. Square root of minus 1 is I, that is plus or minus I, that is you can write 0 plus or minus I. So the given quadratic equation, that is auxiliary equation, has two complex roots. Complex roots always exist in pair. So plus I and minus I are two pair of complex roots for given auxiliary equation. So when we know the formula, when the roots are real and different, or when the roots are real and equal, and when the roots are complex. So depending on the roots, depending on the nature of roots, you can write the solution now. So what is yc? Since the roots are alpha plus or minus I beta form, alpha plus or minus I beta means e power of alpha x into c1 cos beta x plus c2 sin beta x. Here alpha is 0 and beta is 1, therefore yc is e power of 0x into c1 cos x plus c2 sin x. E power of 0x is 1. Yes or no? E power of 0x is 1. So what is the yc? Yc becomes c1 cos x plus c2 sin x. Are getting, guys? This is my yc. Now we have to find yp. Are getting YC from the very first class onwards we are solved in homogeneous. Now in every method of non-homogeneous YC we are getting. So now we are interested in to find what is yp of the problem. So this is yp, the particular integral is 1 by d square plus 1 of e power of 2x plus sine 3x. So here we are having two terms. For the two terms we are separating the yp, that is 1 by d square plus 1 of e power of 2x plus 1 by d square plus 1 of sine 3x. You see, the first term is of method 1 and the second term is of method 2, and separate and apply the method. So e power of x method, at place of d you have to substitute a. So at place of d, let me substitute a, that is e power of x, that is 2 square. So what do you get? 1 by 2 square plus 1 of e power of 2x. 1 by 2 square plus 1 of e power of 2x. That's it. Now coming to the second term, 1 by d square plus 1 of sine 3x. What is a here? It is 3. A is equal to 3 means a square is equal to 9 minus a square is equal to minus 9. So at place of d square you have to substitute minus 9. So what becomes 1 minus 9 plus 1 of sine 3x. So what is yp? Our yp becomes 1 by 5 e power of 2x minus 1 by 8 sine 3x. Are you getting? So this is my problem. Combination of a method. You see, the first term is the e power of 2x, first method sine 3x, second method separate. At place of a you have to substitute 2, d at place of d you have to substitute 2, and at place of d square you have to substitute minus a square. A is equal to 3, a square is equal to 9, minus a square equal to minus 9, so substitute minus 9. So you get yp is equal to 1 by 5 e power of 2x minus 1 by 8 sine 3x. Are you able to get it? So this is my yp. So you got yc and we got yp. What is yc? The yc is c1 cos x plus c2 sin x. This is my yc. Now what is yp? Yp is 1 by 5 into e power of 2x minus 1 by 8 into sin 3x. This is my yp. Now we got yc and yp. Therefore let us write the general solution. So what is the general solution of my first problem? General solution is y is equal to yc plus yp. That is, what is yc? c1 cos x plus c2 sin x. And what is yp? 1 by 5 into e power of 2x minus 1 by 8 into sin 3x. So yc plus yp becomes c1 cos x plus c2 sin x plus 1 by 5 into e power of 2x minus 1 by 8 into sin 3x. So this is my general solution for first problem. Are getting in the single problem we come across it the first method and also the second method. Are getting, guys? Yes, this is my first problem. Let us go to the second problem. Solve. What the problem says? Solve d square minus 4d plus 4 of y is equal to e power of x plus cos 2x. So you see the right hand side. Observe the right hand side. All these are the previous questions for 5 marks. They are repeatedly came in end semester examination. Be careful. Okay. So what is right hand side? You see, what is right hand side, guys? It is e power of x plus cos 2x. E power of x plus cos 2x. So e power of x, you have to apply the first method to find particular integral. And cos 2x, you have to apply the second method to find particular integral. You see, the combination of again the two methods, first and second. Are getting, guys? Are getting? So now let us try to do it. Already we did first problem. Similar manner we have to do. Yes. Now right hand side, is it 0? No. Right hand side is non-zero. Once right hand side is non-zero, then the general solution becomes y is equal to yc plus yp, because it is non-homogeneous. Right hand side is non-zero means non-homogeneous. Non-homogeneous means general solution contains two terms, yc and yp. So let us find first of all yc, that is a complementary function. So what is a complementary function? It is a general solution of corresponding homogeneous differential equation. So how to solve homogeneous? Take auxiliary equation. M square minus 4m plus 4 is equal to 0. M square minus 4m plus 4 is equal to 0. That can be written as m square minus 2 into m plus 4 can be written as 2 square. What is of this form? It is of the form a square minus 2ab plus b square. A square minus 2ab plus b square. So what happens? That is a minus b whole square, that is m minus 2 whole square. M minus 2 into m minus 2 is equal to 0. That is m is equal to 2 comma 2. Now once you get the roots of this auxiliary equation, depending on the roots, we write its solution, that is a general solution. When the roots are real and different, that is the first case. When the roots are real and equal, that is the second case. When the roots are complex, that is the third case. In previous problem, the third case came. Now the roots are real and equal. 2 comma 2 real and equal case, yc is equal to what happens? C1 plus C2x into e power of 2x. C1 plus C2x into e power of 2x. Are getting? This is my yc since the roots are real and equal. So here in turn, what is happening? These problems, these are covering homogeneous, these are covering non-homogeneous. Non-homogeneous, not a single method, they are covering one or two methods. So such a type of problem comes in examination. Keep in mind. So this is my yc, c1 plus c2x into e power of 2x, since 2 comma 2 are my two real and equal roots. So this is yc we got. Now let us go to yp. So what is yp, guys? Yp is equal to 1 by d square minus 4d plus 4 of e power of x plus 1 by d square minus 4d plus 4 of cos 2x, because we have to separate for e power of x, the first term, and for cos 2x, because two methods. In a single method we cannot take it up. So what I am doing is I am applying e power of x and cos 2x separately, the two separate terms. Now the first method, e power of x. E power of x where a is equal to 1. So substitute at place of d, you have to substitute 1. You get 1 by 1 square minus 4 into 1 plus 4. Coming to the next one, cos 2x means a is equal to 2, a square is equal to 4, minus a square equal to minus 4. So at place of d square you have to substitute minus 4. That is 1 by minus 4 plus 4d plus 4 of cos 2x. So what happens? Next step, 1 by 1 minus 4 plus 4 plus 4 minus 4 cancel, e power of x minus 1 by 4 of 1 by d. D means derivative you have to do. 1 by d means you have to do integration. That is minus 1 by 4 of 1 by d of cos 2x. That is integration of cos 2x dx plus 4 minus 4 cancel. Minus 1 by minus 4d minus 1 by 4 cancel. Outside 1 by d of cos 2x. 1 by d means the derivative. 1 by d means integration. So e power of x minus 1 by 4 into integration of cos x is sin x. Integration of cos 2x is sin 2x by 2. So what is the next step? E power of x minus 1 by 4 into sin 2x by 2. Now what is yp? So my yp is e power of x minus sin 2x by 8. So this is my yp. Are getting? There are two methods, first and second. For it, first method at place of d substitute 1, second method at place of d square substitute minus a square, and you are getting 1 by d. D means derivative, 1 by d means integration. That you get the general, that is yp we got. So now what is the general solution? General solution is yc plus yp, yc plus yp. So what is yc? We got yc is c1 plus c2x into e power of 2x, and yp is e power of x minus sine 2x by 8. Now the general solution is yc plus yp, that is c1 plus c2x into e power of 2x plus e power of x minus sine 2x by 8. This is the general solution for my second problem. So let us quickly move on. How much time remains, guys? So exactly it is 25 minutes to go. Yes, 25 minutes to go. So let me take up my problem quickly. This is my problem. Solve d square plus 4 of y is equal to e power of 2x plus sine 2x plus cos 2x. So right hand side, you can observe right hand side what is there here? E power of 2x sine 2x plus cos 2x. So first and second method, again combination of first two methods here. So you have to apply two methods to find particular integral, and right hand side is non-zero, it is non-homogeneous. Therefore general solution consists of two terms, y is equal to yc plus yp. Now first of all find yc, complementary function. So complementary function means general solution of corresponding homogeneous differential equation. Take right hand side 0 and write auxiliary equation. What is auxiliary equation? M square plus 4 is equal to 0, that is 4 to this side, m square is equal to minus 4, that is m is equal to plus or minus 2i, that is m is equal to, you can write 0 plus or minus 2i. Complex roots. When the roots are alpha plus or minus I beta, then what is yc? You can write e power of alpha x to c1 cos beta x plus c2 sin beta x. What is here alpha? Alpha is 0, beta is 2. Therefore you can write yc is equal to e power of 0x into c1 cos 2x plus c2 sin 2x. What is e power of 0x means e power of 0. E power of 0 means 1. Therefore yc is equal to c1 cos 2x plus c2 sin 2x. This is yp. yc we are finding in every problem it has come across up to now. I think you are familiar about this. We got what is yc. yc is equal to c1 cos 2x plus c2 sin 2x. Now yp. Let us go to yp now. So what is yp, guys? The yp is 1 by d square plus 4 of e power of 2x plus sin 2x plus cos 2x. Now, how many terms? How many terms in right hand side? You have 3 terms. E power of 2x by first method, sin 2x from second method, and cos 2x by third method. So, separate the terms. Separate the terms for e power of 2x, sin 2x, and cos 2x. So, what will you get? So, for first one, 1 by d square plus 4 of e power of 2x. Second one, 1 by d square plus 4 of sin 2x. Third one, 1 by d square plus 4 of cos 2x. Now the first method, e power of x, e power of 2x, here are having at place of d you have to write a, that is d at place of d you have to write 2. So 1 by 2 square plus 4 of e power of 2x. Now coming to the second term, 1 by d square plus 4 of sin 2x. At place of a we are having 2, a square minus 4 minus a square minus 4. So at place of d square now substitute minus 4 plus 4 becomes a 0. Now you have to go for formula 1 by d square plus a square of sin ax. 1 by d square plus a square of sin ax is minus x by 2a cos 2x. So this is my 2 is a is equal to 2, so minus x by 2 into 2 of cos 2x. Again the third term, what you are having, 1 by d square plus 4 of cos 2x. A is equal to 2, a square is equal to 4, minus a square is equal to minus 4, minus 4 plus 4 becomes 0. Now apply the formula 1 by d square plus a square of cos x. 1 by d square plus a square of cos x is x by 2a into sin x, that is x by 2 into 2 sine 2x. So what is our final answer of yp? Yp is 1 by 8 into e power of 2x minus x by 4 into cos 2x plus x by 4 into sine 2x. We got yp. Now we got both the terms, that is yp we got, and you also got yc. What is yc? c1 cos 2x plus c2 sin 2x. And what is yp? 1 by 8 into e power of 2x minus x by 4 into cos 2x plus x by 4 into sin 2x. So we got yc and yp. Therefore my general solution. What is my general solution? The general solution is, now the general solution is y is equal to yc plus yp. So that is y is equal to c1 cos 2x plus c2 sin 2x plus 1 by 8 into e power of 2x minus x by 4 into cos 2x plus x by 4 into sin 2x. Thus this is my general solution for the given third non-homogeneous differential equations, which is a combination of methods. Are getting? These are all combination of methods, guys. So 3 problems we covered, another 20 minutes remaining. So let me go to the next problem. So this is the fourth problem. Solve d square minus d minus 2 of y is equal to e power of x plus cos x. E power of x plus cos x. Again, the combination of first and second methods. The combination of first and second method. So right hand side, what is right hand side, guys? The right hand side is e power of x plus cos x. So it is not 0, therefore it is non-homogeneous differential equation, and the general solution contains what? The general solution is y is equal to yc plus yp. So general solution consists to 2 terms, yc plus yp. What is yc? Complementary function. It is a general solution of corresponding homogeneous differential equation. So given non-homogeneous, put right hand side 0, right auxiliary equation. What will get? It is m square minus m minus 2 is equal to 0. So auxiliary equation is m square minus m minus 2 is equal to 0. Now try to take the factors. You can write minus m as minus 2m plus m. If you add minus m, if you multiply minus 2, that gives. So from first 2 terms, take m common. So what you get? M into m minus 2. From next 2 terms, take 1 common, 1 into m minus 2. Now take m minus 2 common. Take m minus 2 common. M minus 2 into m plus 1 is equal to 0. Are you getting? M is equal to 2 comma minus 1. The 2 comma minus 1 are real numbers and they are different real numbers, therefore roots are real and different. Roots are real and different. So we have already in the very first class, I told you that when the roots are real and different, depending on the nature, you can write the general solution. When the roots are real and different, what is my solution? When the roots are real and distinct, real and equal, what is my general solution? And when the roots are complex, what is my general solution? Already I told you. Now the roots are 2 comma minus 1, real and different, real and distinct. Therefore my solution is yc is equal to c1 into e power of 2x plus c2 into e power of minus x. So you got yc, the of solution, yc plus yp. In that you are able to find yc. So what is yc? Yc is equal to c1 into e power of 2x plus c2 into e power of minus x. You will erase everything. So let us go to the yp, the second term. What is yp? What is yp? 1 by d square minus d minus 2 of e power of x plus cos x. For e power of x, you have to solve by first method, and for cos x, you have to solve it by the second method. Are you getting? So separate the terms, first and second method. First one, 1 by d square minus d minus 2 of e power of x. The second one, 1 by d square minus d minus 2 of cos x. So in first case, e power of x, that is e power of x, you are having a is equal to 1, at place of d substitute 1 by 1 square minus 1 minus 2 of e power of x. And second case, again a is equal to 1, a square is equal to 1, minus a square equal to minus 1, so at place of d square substitute minus 1. So what happens? This is minus 1 by 2 into e power of x minus d minus 3 minus outside d plus 3. In denominator we are having, what we are having in denominator, d plus 3. But the method says, the second method, sin x or cos x method, replace d square by minus a square. Now we aren't having d square, we are having d plus 3 in the denominator, so we have to convert into d square. Already when I explained the second method, I told you. So multiply and divide with the rationalization, that is d minus 3 by d minus 3. So what you will get? 1 by minus 1 by 2 into e power of x minus d minus 3 by d plus 3 into d minus 3, that is a square minus b square, that is d square minus 9. At place of d square substitute minus 1, you get minus 1 by 2 into e power of x minus d minus 3 by minus 1 minus 9 of cos x. So that is minus 1 by 2 into e power of x plus 1 by 10 into d minus 3 into cos x. What is d? D means, what is d? D means the derivative. 1 by d, in the first problem itself we got come across it, 1 by d. 1 by d means you have to do integration, and d means you have to do derivative. So derivative of cos x is minus sin x, minus 3 into cos x. So this is my yp. What is yp? Minus 1 by 2 into e power of x plus 1 by 10 into minus sin x minus 3 cos x. This is my yp. We got yp. Are you getting, guys? So this is a method. Two methods are there, e power of x and cos x. So first method, very easy, at place of d substitute 1, you get the answer. And the second method, if at place of d square must be replaced by minus a square. Here a is 1, a square is 1, minus a square is minus 1. So at place of d square I am putting minus 1. So d minus 3 minus outside d plus 3 you get. But denominator, if it is, there is a d square, it is a d square, then it must be replaced by minus a square, that is minus 1. But in denominator we are having only d. You have to convert it into d square, means rationalization d plus 3 have multiply and divide with d minus 3. D minus 3 by d plus 3 into d minus 3, d square minus 3 square, that is 9. So at place of d square write minus 1, that completes. But d minus 3 of cos x, d means derivative, 1 by d means integration. So d of cos x, derivative of cos x is minus sin x. At last you are able to get yp. What is yp? That is minus 1 by 2 into e power of x plus 1 by 10 of minus sin x minus 3 cos x. So this is my yp. Are you getting? So we are able to find the yp and we are able to find yc. What is yc? c1 into e power of 2x plus c2 into e power of minus x. This is my yc. And what is my yp? It is minus 1 by 2 into e power of x plus 1 by 10 into minus sin x minus 3 cos x. Are you getting? So we got yc and yp. Now you can write the general solution. So excuse me. Now, what is the general solution? The general solution is y is equal to yc plus yp. That is, now here I written only yp. Okay. You have to write yc plus yp. What is yc? What is yc, guys? What is yc? c1 into e power of 2x plus c2 into e power of minus x plus yp. What is yp? Minus 1 by 2 into e power of x plus 1 by 10 into minus sin x minus 3 cos x. So this is my general solution, that is y is equal to yc plus yp. Are you getting? Yc plus yp is my general solution. So don't left it there yc plus yp. You have to write yc and plus yp, then only the problem ends. That is the fourth problem. So see, the time is it's another, I think, 20 minutes more. Yes. It's another 20 minutes more. So this is my fourth problem. Now let us go to the fifth problem, guys. The fifth problem, you see. What is my fifth one? Solve. Solve. Yes. Why it is? Okay. I think it is clear now. Yes. What is my problem? The fifth problem is d square plus 3d plus 2 of y, d square plus 3d plus 2 of y is equal to sin x plus x square. It is sin x plus x square. So for sin x you have to apply the second method in finding particular integral, particular solution, that is yp. In yp I am telling. In yp, for sin x you have to apply the second method. For x square you have to apply third method. Are you getting? Yes. So this is a combination of second and third method. Second and the third method. So, first of all, let us start. So right hand side is non-zero, means it is non-homogeneous. Once it is non-homogeneous, the general solution is yc plus yp. General solution is yc plus yp. Are you getting? Yes. Now my general solution contains two terms. Y is equal to yc plus yp. Are you getting? What is yc? Complementary function. Complementary function means the general solution of corresponding non-homogeneous differential equation. So given non-homogeneous, in a non-homogeneous, put right hand side 0. What it becomes? That is d square plus 3d plus 2 of y is equal to 0. In the given problem itself, put the right hand side 0, that is d square plus 3d plus 2 of y is equal to 0. Are you getting? It is equal to 0. So now that becomes our corresponding homogeneous differential equation. So how to solve it? The right hand side 0 means it is homogeneous. How to solve homogeneous? I given in the very first class. What is that? So at place of d you have to write m and remove y, then you will get auxiliary equation. As the auxiliary equation is quadratic in nature, it is a quadratic equation. So find the factorize a quadratic equation, or otherwise use the formula that the roots is equal to minus b plus or minus square root of b square minus 4ac by 2a. So use the formula or factorize to get the roots. Once the roots are we got, if m1 and m2 are two real and different roots, then the solution is c1 into e power of m1x plus c2 into e power of m2x. This is the case where the roots are real and different. If the roots are real and equal, the case I am telling real and equal, that is roots are m comma m. Two roots are equal. Then the solution becomes, general solution is c1 plus c2x into e power of mx. When the roots are complex, the third case, when the roots are complex, that is alpha plus or minus I beta. E power of alpha x plus c1 cos beta x plus c2 sin beta x. This is a case where the roots are complex. So there are three nature of roots. Three cases. Roots are real and different. Roots are real and equal. Roots are complex. Now that is how we solve homogeneous. Now we got what is homogeneous. Corresponding homogeneous differential equation is d square plus 3d plus 2 of y is equal to 0. Yes, it is equal to 0. So auxiliary equation. So what is auxiliary equation? M square plus 3m plus 2 is equal to 0. m square plus, at place of d you have to write m and remove y. So what you got, the auxiliary equation is m square plus 3m plus 2 is equal to 0. You got the auxiliary equation. Now factorize. It is an auxiliary equation, is a quadratic equation. Now factorize, find the roots. Depending on nature of roots, you can write yc. So 3m can be written as 2m plus m. Why? 2m plus m, if you add, you will get 3, and if you multiply, you will get 2 into 1, that is 2. You are doing factorization to get the roots. So from among the first two terms, take m common, you get m into m plus 2. And the next two terms, take 1 common, you get 1 into m plus 2. So this is my next step. M into m plus 2 plus 1 into m plus 2 is equal to 0. M plus 2 common, m plus 2 into m plus 1 equal to 0. Now the roots are m is equal to minus 1 comma minus 2. The roots are real and different. Therefore my yc real and different case. So what is that? It is c1 into e power of minus x plus c2 into e power of minus 2x. We are able to find yc. Now let us try to find yp. Let us find the yp. This is my yp. Okay. S yp. Excuse me. So what is yp? 1 by d square plus 3d plus 2 of sin x plus x square. Sin x. How to find particular integral in case of sin x? In case of sin x, what to do? You have to apply the second method. Whereas plus x square, for x square you have to apply the third method. So this is a combination of second and third method. So this problem checks your knowledge on the method 2, on the method 3, and not only method 2, method 3 of non-homogeneous, it is also checking the knowledge of homogeneous. So many concepts are verified here. That's why such a problems comes in examination frequently for 5 marks. Are you getting? So this is the combination of two methods. First the sin x, that is the second method, and the third method, second term x squared, that is the third method. So separate. So better you separate. This is 1 by d square plus 3d plus 2 of sin x, and what is this here? 1 by d square plus 3d plus 2 of x square. Are getting? 1 by d square plus 3d plus 2 of x square. For sin x, coming to the first, for sin x, a is equal to 1, a square is equal to 1, minus a square equal to minus 1. So in the second method, sin x or cos x, you have to replace the d square by minus a square. So minus a square is minus 1. So I am replacing d square by minus 1. Here, the next step, here you have to come across x square. So working will consist of two-step process. First of all, you have to take least term of d common. So what is my first term? D square power 2, 3d power 1, 2 means power 0. So 2 is the least power of d. So take 2 common. At place of 2 you will get 1, and d square plus 3d, you will get d square plus 3d by 2. Now here next term, minus 2 plus 2 minus 1 plus 1, 1 by 3d plus 1 of sin x, and here 1 by 2, 1 plus d square plus 3d by 2 whole power of minus 1. Now the denominator contains only d, but the second method tells us you have to replace d square by minus a square. So we need d square. No d square, so that's why rationalization of denominator, multiply and divide by 3d minus 1 by 3d plus 1. That is 1 by 3d plus 1 into 3d minus 1 by 3d minus 1 into sin x. And here we are using the formula 1 plus d whole power of minus 1. Plus minus means first you are having plus and power you are having minus, so the formula is plus minus like that. Plus 1, that is 1 minus d plus d square minus d cube plus d power 4 and so on goes on. 1 minus d plus d square minus d cube plus d power 4 and so on. But at place of d you are having d square plus 3d by 2. Now substitute 1 minus d square plus 3d by 2 plus d square plus 3d by 2 all square and so on. This is my next step. Now 3d minus 1 by what you are having, 3d minus 1 into 3d plus 1, that is a minus b into a plus b, that is a square minus b square. So 3d whole square is 9d square minus 1. So then this is a step 3d minus 1 by 9d square minus 1 of sin x plus 1 by 2 1 minus d square plus 3d by 2 a plus b whole square, d square plus 3d whole square, d square means d square whole square, d power of 4, 2ab means 2 into 3d into d square, 6d cube plus 3d whole square means 9d square by 2, 2 whole square means 4, you get this, you got that, okay. Now at place of d square, here second method, at place of d square replace d square by minus 1, replace d square by minus a square, a is 1, a square is 1, minus a square is minus 1. So at place of d square minus 1, minus 9 minus 1 is minus 10. So minus 1 by 10 of 3d minus 1 of sin x. And coming to here, 1 into x square is x square. Derivative of x square, 2x. Second derivative of x square, 2x derivative 2. Third derivative 0, fourth derivative 0, fifth derivative 0 and so on. So at place of d you have to write 2x and at place of d square you have to write 2. So that's what we are writing here. You see at place of d square 2 plus 3 into d means 2x by 2 and d power of 4. Third derivative onward 0. So d power of 0, d cube 0 and d square you have to write. So you got this. Now what is d? D means derivative. So minus 1 by 10, 3 into derivative of sin x. Derivative of sin x is cos x, minus 1 into sin x is. So we got the second method. Now coming and simplify here, 1 by 4 into 2x square minus 6x plus 7. So this is my yp, minus 1 by 10, 3 cos x minus sin x plus 1 by 4, 2x square minus 6x plus 7. So this is my yp. Are you getting? So we got yp. So somewhat lengthy problem I took so that you can understand very carefully. Are you getting? There are two terms, sin x. For sin x you are separating and x square we are separating. For sin x, replace d square by minus a square. Minus a square is minus 1. You are putting minus 1. It becomes 3d plus 1. But in denominator, only d term is there. We have to convert into d square. So rationalization and a plus b into a minus b, a square minus b square. You got 3d minus 1 by d square minus 1. At place of d square, substitute minus 1. You will get minus 1 by t. 3d minus 1 of x. D means derivative. Derivative of sin x is cos x. So for the second method, for sin x term, what we got, minus 1 by 10 into 3 cos x minus sin x. Now here third method, least power of d common, you got 1 plus d square plus 3d by 2, taking to the numerator, what you got, 1 by 2, 1 plus d square plus 3d by 2, whole power of minus 1 of x. Apply the formula 1 plus d whole power of minus 1. What is that? 1 minus d plus d square minus d cube and so on. At place of d we are having d square plus 3d by 2. Substitute, you get this. Now x square, 1 into x square, derivative of x square is 2x. D square of x square is 2, d cube 0, d power of 4 0, d power of 5 0. So at place of d you have to write 2x, at place of d square you have to write 2. So 1 into x square, it is x square, d square 2 and d it is 2x, d power of 4 0, d cube 0, d square 2. Substitute and simplify, you got yp. So what is my yp? My yp is minus 1 by 10 into 3 cos x minus sin x plus 1 by 4 into 2x square minus 6x plus 7. It's a combination of second and third method. Are you getting, guys? So this is my yp. Therefore, the general solution is y is equal to yc plus yp. What is yc and what is yp? Write down both. Don't end here. Don't end here. Are getting? Don't stop here itself. You have to write what is yc and you have to write what is yp. Clearly, don't end simply writing the solution is yc plus yp. You have to write what is yc and what is yp. Practice. That is the same thing I'm doing in the video, so that you get such a good habit. So what is it? So what is the general solution? The general solution y is equal to, what is the general solution? Y is equal to c1 into e power of minus x plus c2 into e power of minus 2x plus 1 by 4 into 2x square minus 6x plus 7 minus 1 by 10 into 3 cos x minus sin x. This is the general solution of the fifth problem. Are you getting? So this is the topic, that is combination of methods we are doing. So 5 problems we covered, and the time 2-3 minutes left, so we cannot cover one more problem, so we end the class here. So practice. So what I am telling is, you know the method 1, you know the method 2, method 3, that is the right hand side is e power of x, and if the right hand side is sin x or cos x, or if the right answer is x to the power of m. So the 3 methods I explained, I have done the problems, I given the homework, you made the homework also. Now the combination of these 3 methods we are doing. So first of all, practice these. First of all, read the method 1, method 2, method 3, and then practice. This solved problems of this video. We covered at about 5 problems. All those 5 problems are previous questions. They are previously came many number of times. So practice these 5 problems, then only go to the homework. So this is a time to give homework, guys. So what I am telling, keep in mind, first of all, read the method 1, method 2, method 3, understand the procedure, the working rule, then practice these 5 problems, the solved problems. Whenever you can doubt, you can go to the solution and check, and once you are you can able to do it all, practice these 5 problems, then only you start the homework problem. Are you getting, guys? So this is a time of homework. So this is my homework. So what is that? D square minus 4d plus 3 of y is equal to e power of 2x minus sin 3x. First and second method. The second one is d square plus d plus 9 of y is equal to 25 plus sin 3x. Again 25. What to do in this case? 25 can be written as 25 into e power of 0x. That's the first method. Sin 3x, that is the second method. Combination of first and second. The third problem, last problem, is d square plus 4d plus 4 of y is equal to e power of minus 2x plus x square. Again, combination of first and the third. X square, x to the power of m form. That is the third method. So these are the combination problems of methods 1, 2, 3. So practice them. Once you are able to do these problems, means you have a good idea on all the 3 methods. So these 3 problems, if you are able to, then you can do any problem of the chapter, any problem of the lesson, that is solving non-homogeneous differential equation by using the 3 methods. First one, right hand side e power of x, second one, right hand side sin x or cos x, and third one, the right hand side is x to the power of m. So combination problems you are able to do, means you can do any problem of the type, any problem of the chapter. So that's it, guys. So with this we completed the syllabus. So thank you very much. Thank you, guys. Stay home, stay safe, stay healthy. See you tomorrow with other topics. See you guys. Bye.